All right, so we're going to look at surface area and volume of cylinders. In order to do this, we first have to look at the parts of a cylinder. So cylinders have a circle on the top and the bottom, and then there's like a really long rectangle that's been bent around to make what they call the lateral side here. The pieces that we need to know to do surface area and volume are the radius, which is what this arrow is pointing to, that distance from the center to the outside of the circle. And then you would also need to know the height. And the height is considered the distance between circles, even if they're set on their sides. So let's draw a little picture down here. I'm going to draw like a little oval and just make it look like a cylinder that's on its side. So your radius is from the center to the outside. That's your radius, or R. And then the height, which I always thought was weird if it's sideways, is this. Even though it's not standing up and down, they still consider this to be the height. So the height is technically the distance between the two circles. Okay? The formula that's going to go in this box has SA for surface area, and I don't know if this box doesn't look big enough, but we'll try to squeeze it in. It's 2 pi RH plus 2 pi r squared. So I almost fit it in the box, but not quite. And I'm going to tell you which parts are which. So pi r squared would be one of the circles. There's two of them because there's two circles in a cylinder. So this would give you the area of just the circles. And this part right here, the 2 pi r, would give you the radius of the circle. And then there's the height. So if you actually unfolded this and made the side into a big rectangle, basically this would give you the base times the height of that rectangle. And so this would be the side. And they sometimes call that the lateral area, but that's not a big deal for what we're doing today. So R is the abbreviation for radius, and H is the height. And I guess I have capital H on here. We could make this capital H, but I don't know that it's a big deal for this formula. So 2 pi RH plus 2 pi r squared. There's two pieces because this is the area of the big, long, curved side, and this is the area of both circles. And so if you were doing a cylinder that didn't have the top and bottom, like it looked like a tube from a paper towel roll or something like that, you could just leave that part off and it would just give you the side. Okay, so let's take a look at this problem. It says find the surface area. So the first thing you have to do is locate the radius and the height. So my radius is going to be 9. My height is going to be 6. So our formula is 2 pi RH plus 2 pi r squared. Since I had it so squished on that other box, I'll write it out a little bit bigger here. And then you'd literally just take the 9 for radius and the 6 for height and put them in. So I'm going to have 2 times pi times 9 times the height, which would be 6, and then 2 times pi times 9 squared. Okay? And for the most part, we could just type this into our calculator. So let me go through that. And I'm just going to use the pi key. I'm going to use the pi key, but realize if you were on a standardized test and they told you to use 3.14, that you would want to
do you need
do
to
that.
use parentheses for pi?
So I use parentheses to sort of highlight the numbers that I put in. You could just put times dots, but then sometimes people think they're decimal points. So I like parentheses just because it keeps everything separated and doesn't look like 96 or 9.6. That's why I did that. Okay, so I'm going to do 2, and then pi is up above this key right here. So I did second and pi, and then times 9 times 6 plus 2 times pi times 9 squared. And then we're just going to go ahead and round off to the tenths. Do whatever your directions say. 848.2. And this is inches, and it's surface area, so it's going to be inches squared. For area, we use squared. Now, just for fun, let me go through what this would look like if you used 3.14. Would have 2 times 3.14 times 9 times 6 plus 2 times 3.14 times 9 squared. And it comes out just a little bit different, 847.8. So realize a lot of times in standardized tests, they may have you use 3.14 because then you don't have as much rounding to think about. But notice the answer does come out a little different. This is 847.8 and we got 848.2. So that's off by about 4/10.
Would you still accept it?
So you need to use for pi whatever it says in your directions. If it doesn't say in the directions, you can use in the pi key. If it says to use 3.14, you need to use 3.14. So normally on standardized tests, they're going to tell you to use 3.14 because it does make the answer a little simpler to look at. Okay, so let's do another one.
Where is the pi key?
I already showed that. I will when I do the next one. Okay, so we just recorded all of that. On the next problem, we need to locate the radius and the height. The height's pretty easy. That's 12 meters over here. Now, we have 5 meters going all the way across. That's diameter. So for radius, I need halfway.
Which is 2.5.
So I'm going to take 5 divided by 2, and my radius is 2.5. So they did not give us the radius. We just calculated it.
Oh, that's smart.
Okay? So everybody understands what we just did. All right, so then we're going to use our formula, 2 pi r h plus 2 pi r squared. We're just going to put the numbers in. So I'm going to have 2 times pi. The radius is 2.5. We just found that. The height is 12. And then 2 times pi times the radius squared, which is 2.5 squared. If you use 5 instead of 2.5, your answer will come out way, way bigger than it should. So that's why I wanted to go through this with you guys and make sure we get this down. So let's go through how to put this in on the calculator. So you're going to type 2, and then the pi key is right here. You have to hit your second, and then that, and you get pi. Then times 2.5 times 12 plus 2 times pi times 2.5 squared. Okay, and we get 227. If I want to round it off to tenths, I have 0.76. So that would round up to 0.8. This is in meters, so meters squared. Let me try to write that a little bit neater. So 227.8 meters squared. Okay? So that's surface area and how to use the surface area formula. I like volume because the formula is a little bit shorter. Okay? So for volume, we're going to use the same pieces. This is the radius, and then this distance on the side is the height. There's a little rectangle that kind of printed there. I don't know why. Just ignore it and write height over the top. And the volume formula is a lot shorter. It is pi r squared h. So the pi r squared is the area of the circle base, and then the h is the height. So you can think of it as being like length times width times height, but the pi r squared is how you get the length times width part on the bottom, which is the area of the circle. So pi r squared h. And radius is still r, and h is still height. So that's just the same pieces of the cylinder that we used for surface area. Okay, so pi r squared h is the important thing, and I'm sorry the box is so small. Write it somewhere else if it won't fit.
So pi
R squared h. So pi r squared gives you the area of the circle, so that's kind of like doing length times width on our rectangular prisms that we had, and then you add height to it to get that third dimension for volume. All right, so here's a couple of examples. So my radius is 9, and my height is 6. So I literally just need to do pi r squared h. So that'd be pi times 9 squared times 6. And you don't have to use parentheses. I just like to do that to show how I put the numbers in. So we're going to do pi times 9 squared times 6. And if we round off to tenths, this would be 1,526.8. And for volume, what would my label be?
3.
To the third. Good. So inches cubed. So for surface area, it's squared. For volume, it's cubed. So this is a pretty simple formula.
Yeah.
And then on our last example, I used the same one that we did for surface area. So the 12 is your height, but 5 is not the radius. Why not?
Because it was all the way across.
Because it goes all the way across. It makes it diameter.
So then
So the
2.5.
radius, I've got to take 5 and
2.5
divide it
again.
and get 2.5 again. So I'm going to do pi times r squared times h. So I'm going to do pi times 2.5 squared times 12.
You should get 235.
So we'll put it up here. We'll get pi times 2.5 squared times 12. I got 235.6. So 235.6, and this would be meters cubed.